Okay, so now let's look at example 1. We're going to take this linear equation, y is equal to 3x plus 1. And we're going to, here are our steps. Choose an x value, and remember we always talk about working smart, not hard. To solve for y. We're solving for y, so we get to choose this. By the way, what do we call the values we get to choose? It's a variable. What kind of variable? Remember there are two kinds, independent and dependent. Which ones do we get to choose? It could be anything, the independent or the dependent. Independent. The independent we get to choose, and remember y is going to be dependent on whatever we choose for x. So we get to choose this. Somebody who's going to work smart, not hard, tell me what we want to make our x values. Yes, sir. Sorry? 1. We want to make it 1. Give me another one. 0. Give me a third one. -1. Work smart, not hard. So in this space, I'm going to take this equation, 3x plus 1, and I'm going to solve it 3 different times, plugging in these different values for x, and then solving for y. So the first time I'm going to solve it, I'm going to plug in what for x? 1. I'm just going to write down our 3 equations. The next time I solve it, I'm going to plug in a 0. The last time I solve it, I'm going to plug in a -1. And then we're going to use order of operations. It's easy from here, guys. I think because it's so abstract, take an equation, fill in a table, graph it, we kind of got lost somewhere in translation, but it's not that tough. It's not as tough as it looks. It's just weird. It's just different. Order of operations say we got to multiply before we add. 3 times 1 is 3. 3 plus 1 is 4. So when x is 1, y is 4. Here's our first ordered pair. 1, 4. When x is 0, 3 times 0 is 0 plus 1 is 1. Thank you. So when x is 0, y is 1. That's our next ordered pair. X was 0. We solved for y, it's 1. Here's our last ordered pair. When x is -1, 3 times -1 is -3, plus 1 is negative. Actually, we've got negatives and positives. So remember, they're kind of fighting against each other. There are more negatives than positives, so the negatives would win. But we would subtract -2. And I saw my girl in the back holding up 2, -2. So here's our last ordered pair. -1, -2. I'm running out of room. I tried to get everything on the board. So these 3 ordered pairs, guess what, belong to this equation. They are 3 of an infinite number of solutions that will go on the line of this equation. And then I'm just going to sketch the graph for sake of time. I wish I had passed you guys stickies of the graph. You will have one on your practice. It's already printed on there for you. But just roughly sketch that for me. +1, +4, over to the right 1, up 4, about here. 0, 1, because this is 0, you're not going left or right, you're just going up 1. That's about here. And the -1, -2 is about, that's a little too low, about here. And then what should they form if I did this right? A line. Always connect those points with a line. Hence linear equation. Okay, example 2 is a little different. What's a little different about example 2? Yes, sir?
You're solving for x.
Ooh, you're solving for x. No, they didn't. Yes, they did. Now they want you to solve for x. So we could use all kinds of algebra, and before the break, that's what I suggested that you do. But guess what? If you're solving for x, then why don't you choose your y values? So we're so used to choosing our x values, but now that we're a little more familiar with this, since this is on the other side of the equal sign, why don't we make y our independent variable that we get to choose? That way, we can just use order of operations to solve for x. So somebody who's going to work smart, not hard, my young lady in the front, and the lovely black and white sweater, give me 3 values for y.
1, 0,
Yep. I like the way you think. You're working smart, not hard. 1, 0, negative 1. But I chose my y's this time. You don't have to do this. I'm just trying to save you some algebra, even though we are doing algebra.
Let's do it again.
Can you please shut the door? I want to use your names. I'm sorry. Okay, so we're going to do the same thing. In this space, I'm going to go ahead and write our equation. Thank you so much, sir. I'm going to solve this equation 3 different times. The first time I solve it, I'm going to plug in a 1. Help me out. The next time I solve it, I'm going to plug in a what?
A 1.
I already did that.
0.
0. Thank you. And the last time, I'm going to plug in a negative 1. And this is totally weird for us because we are so used to solving for y. But because this is by itself on this side of the equal sign, let's solve for x this time. Using order of operations. Negative 2 times a positive 1. Think of your faces. Negative, positive. Looks like he's not feeling too well. I'm going to get a what kind of a number here? Positive or negative? Negative 2 times positive 1. Different signs. When we multiply, it's going to be negative. And a negative 2 plus positive 4. Again, the signs are different. Positive 2. Anything times 0 is 0. So we get 0 plus 4 here, which is 0 plus 4 is 4. Here the signs are the same. Negative times a negative give me a positive. So negative 2 times negative 1 is, well, it's positive 2, and positive 2 plus 4 is 6. So here are my ordered pairs. X is 2, where y is 1. X is 4, if y is 0. And x is 6, where y is negative 1. And then again, I'm just going to sketch this graph. You guys are doing awesome. Roughly 2, 1, over 2, up 1, about here. 4, 0. We go all the way over to 4. We're not going to go up or down because that y value is 0. And then 6, negative 1. It's going to be about here. And then, of course, we're going to connect those points with a line.